Welcome to another installment of Mind Your Math. My name is Collins Mackenzie. I just wanted to remind you guys that if there's any question that you would like to ask, go to our social media pages. As always, at the bottom left is mine, and on the bottom right is Sesh Towns. So please do contact us and give us any other alternative methods that you use to solve your problems. Mind your math. Take out your calculators. Let's do it. Today, we're continuing with sequences. Now, yesterday, or perhaps last time, we dealt with arithmetic sequences. Today, we're moving on, we're doing geometric sequences. Very similar, some call them sisters, but I see the differences in between the two sequences. Now, the geometric sequence is one in which to obtain the next term, you have to multiply the previous term by a common ratio r. How do you obtain that common ratio r? Take, for example, the sequence 2, 4, 8, and 16. Now, what the geometric sequence does is that in order to obtain the next term, you have to multiply the last term or the previous term with the common ratio r. So, the opposite must be true. 4 divided by 2 must give us 2. 8 divided by 4 must give us 2. 16 divided by 8 must give us 2. So the common ratio r is what differentiates the arithmetic sequence from the geometric sequence. Let's continue. The formula for a geometric sequence, which is a general formula, is Tn equals Arn minus 1. Let's define what every variable in the general formula represents. A represents your first term. R represents your common ratio. And the rest of the variables, which is Tn and n, represent the value and the term number as we spoke about last time. You can find the formula on your formula sheet. It should be given to you in every exam. Today's lesson is on the geometric sequence. Like last time we spoke about the arithmetic sequence, the geometric sequence is one in which to get the next term in the sequence, you have to multiply by a common ratio r. Now the common ratio r is obtained by dividing the consecutive term by the previous term. That's how we find it. And let's take, for example, a sequence like 2, 4, 8, and 16. Now, what makes this sequence a geometric sequence is that in order to obtain the common ratio r, all the terms must follow a rule that if you divide the consecutive term by the previous term, it must give you a constant ratio r. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. Now we can see that dividing a consecutive term by the previous term gives us a common ratio r. Let's get to the formula of a geometric sequence. It's found on your formula sheet, which is given to you by every examiner during an exam. The formula is Tn equals Ar to the power n minus 1. This is the formula. A on the formula represents the first term. R represents the common ratio, which we found a minute ago. And Tn is the value of your term. And n is your term number. Let's get to a practical example. In the practical example written down, we are asked to determine the 10th term in the sequence 3, 6, and 12. Now, in order to get the 10th term in this sequence, we must first find the general formula of this particular sequence. 3, 6, and 12. The first thing that we must do is get the common ratio r. And we obtain this by dividing a consecutive term by the previous term. 12 divided by 6 is 2. 6 divided by 3 is also 2. So we have gotten our common ratio R. Now we have to continue in finding the general formula of the geometric sequence. From our formula sheet, we obtain this general formula of a geometric sequence. Now we must find the particular formula for this sequence 3, 6, and 12. We found the common ratio R, which is 2. We have our first term, which is A. A represents our first term. In this case, it's 3. Our common ratio R is 2, then to the power n minus 1. This is the formula for this particular sequence. Now, we are asked to find the 10th term in the sequence. So we have to replace n by 10 because that's what we want. 10 minus 1 becomes 9, and 2 to the power 9 multiplied by 3 becomes the value of the 10th term. Therefore, 2 to the power 9 becomes 512 multiplied by 3 becomes 1536. We're given a practical example. Given the sequence 1, 2 over 3, 4 over 9. Our first question is, determine the next 2 terms in the sequence. I'm sorry, this was supposed to be 2. It's 2. So in order for us to get the next 2 terms in the sequence, we must first find the specific formula for this equation, for this sequence I mean. The first thing we must find is the common ratio R. 2 over 3 divided by 1 is 2 over 3. This means our common ratio R is 2 over 3. The general formula for a geometric equation is A into R to the power n minus 1. And as we've spoken before, A is the first term, which is 1, and R is 2 over 3 to the power n minus 1. This is the specific formula for this geometric equation sequence. So we need to find the next 2 terms in the sequence. We do this by finding how many terms we have already. We have term number 1, term number 2, and term number 3. So we need term number 4 and 5. Term number 4 becomes, wherever you see n, you substitute by term number 4. 4 minus 1. So it becomes 2 over 3 to the power 3. 2 over 3 to the power 3 becomes 8 over 27. 8 over 27 is our term 4. Now we're looking for term number 5. The equation is still Tn equals 1, 2 over 3 to the power n minus 1. So we're looking for term number 5. Wherever we see n, we replace by 5. 1 into 2 over 3 to the power 5 minus 1. This becomes 1 into 2 over 3 power 4. We go to our calculator. We type in 1 into 2 over 3 to the power 4. It gives us 16 over 81. This is our term 5. Moving on to the second question. Which term of the sequence is equal to 32 over 243? They are looking for n. We have our formula Tn equals 1 into 2 over 3 to the power n minus 1. Now we are given Tn, which is 32 over 243. 32 over 243 equals 1 into 2 over 3 n minus 1. We are looking for n in this case. The first thing that we must do is reduce this number to a number that is similar to 2 over 3. 2 over 3 to the power n minus 1. We go to our calculator. 2 times 9, 2 times 12, 2 times 24, 2 times 18, 16. We have 2 times 16 at the top, and 243 divided by 3. We have 3 times 81 at the bottom. Now we're looking to reduce this number into a number that has powers, so we can equal it to the number on the right hand side. So it's 2 times 2 to the power 4 over 3 times 2 to the power 81, 3 to the power 4, 2 over 3, n minus 1. So it becomes 2 to the power 5 over 3 to the power 5 equals 2 over 3 into n minus 1. We have reduced the number on the left to its powers. Now we have an equation like 2 over 3 all to the power 5 equals 2 over 3 to the power n minus 1. Now the laws of exponent tell us that if the bases are equal, we must equal the exponents. So 5 equals n minus 1. Therefore, 1 must go to the other side, and when it changes sides, it must gain a different sign. So it's negative in this side. When it goes to the other side of the equal sign, it becomes positive. So it becomes 5 plus 1, which becomes 6. So n is equals to 6. This means that the 6th term is the one having a value of 32 over 243. That's all for today, folks. It was a nice lesson, and I hope to see you guys soon. Do follow us on our pages, my personal page over here and Searchtown page over here, and stay in touch, man. We want to hear from you. Stay safe, wear your masks, sanitize, social distancing. See you on the next insert.